Hello everyone, welcome back to the channel. I hope you guys are doing amazing. So in today's daily challenge on Leetcode, I will show you two methods to solve the problem. Starting from the brute force method, which involves simulating this whole problem, and also to the optimal method, which involves the use of priority queues. So definitely stay till the end of the video. You will definitely learn something new if you are unable to solve the problem. So let's see what is the question exactly. We are given an integer n. There are n rooms numbered from 0 to n minus 1. You are given the meetings which will be held given by the start time and end time. So you are given some meetings of start time and end time, and you have n rooms, and if you see, n is only 100. Okay, so you have only 100 rooms, and each meeting, there are some conditions in which the order of the meetings will take place. Each meeting will take place in the unused room with the lowest number, and if there are no available rooms, meetings will be delayed until a room become free. The delayed meetings should have the same duration as the original meeting. So when a room become unused, meeting that have a earlier original start time should be given the room. So this becomes very important because this gives us the first idea that we should sort the meetings, right? Because the earlier start time we should process in order of start time. The meeting which is supposed to start first should be allocated first room. Okay, allocated room first. So that gives an obvious hint to sort the meetings. Okay, so we need to return the room number that held the most number of meetings. Okay, so that is the most important room, you can say. And if there are multiple such room, return the room with the lowest such number. And it is in the half closed interval, so it means that if the interval is A to B, it means that not including B. Okay, so these meetings are held like 0 to 9, not 0 to 10. It's given 0 to 10, but the thing is like at 10 you can start some other meeting also. Okay, so you can see the example. You can just go through it of how they are allocating in 2 rooms. Okay, and it is given that how they are allocating in 3 rooms. So you can just check how to solve this problem. Okay, so let's try to visualize this second example. Okay, let's try to visualize this second example. So I will just uh, rub these things. Let's see what is this second example asking us. So it is telling that you have 3 rooms only. Okay, so you have just 3 rooms. Okay, so let me draw 3 dashes. So can't I have one array which will tell me the count array, which will tell me the number of meetings which is being held in every room, because that is what we need at the end, the most important room, the room with the maximum number of meetings. So we have a count array first of all. Okay, and also we have an array which will tell me that if the what is the status of every room. Okay, let's have a status array which will give me the status of every room, which is whether it is occupied, or like what is the ending time of the meeting. So let me do like ending time, it will store. Okay, ending time of meet, it will store. So you will easily get to know whether it is free or not based on the current meeting. You have a current meeting which have a start time. So if the ending time is is has already elapsed, we can just get that, and we can iterate from left to right, because this is the order of the room number which is preferred. Okay, so the very definite and obvious thing which you should understand first is that we need to sort the meetings. Okay, uh, we need to just at first we need to just sort the meetings, uh, because it is quite obvious that the meetings, it is given in the question also, that the meeting which has the earliest start time, we need to allocate that first. Okay, allocate the meeting which has the earliest start times, and therefore we need to sort the meetings. In whatever approach you do, you definitely need to sort it, and then process the meetings in order from 0 to meetings dot size. Okay, so you just do this. Okay, and you see you have some meetings which is, let's say the first meeting is something like 120, 1 to 20. The second one is nothing but 2 to 10, 2 to 10. Okay, the third meeting is nothing but 3 to 5, 4 to 9, and 6 to 8. Okay, 3 to 5. Then you have something like 4 to 9. Then you have something like 6 to 8. Okay, 6 to 8. These are the orders. in which this is, you see already this is sorted. Already this is sorted by the first starting time. So that's not an issue here. So at first you initialize all the count to 0. So what will happen? Initially you are processing this meeting. You see that if there is any free room or not, you go through the status. You check that initially the status is 0, so it means that the ending time is 0. So you see that if the first room, you go to the first room and check if it is available. How you can check if it is available? You can easily just check that whether the ending time which is storing here is less than or equal to the starting time or not. You find that it is less. So what you do, you store the ending time 20. So this first meeting is occupied till time 20. So status will get changed to nothing but 20:00. After the first iteration, the status will get changed to 20:00, and count will be something like 1:00. The first room has one meeting. Okay. Then when you process this, what will happen? You see that it will check first, then it will again go through all these status, and it will check that 20 is already occupied till 20. Okay. And we have this start time of 2, but this is 0 which is unoccupied, so it will occupy this meeting, and it will say that this will get over at 10. So this is nothing, I hope you understand, this is nothing but the status array, and this is nothing but the count array. Okay. So this is okay. This, it says that this room is occupied till time 20, this room is occupied till time 10, this room is occupied till time 0. That is, it is free. Okay. So you see the count now goes to something like this, 0 1 1 0. Okay. Now when you process this element, you see that none of them is less than or equal to 3. So you just have to do something like 20, 10 and 5. So this will get over at 5, and you have the count of meetings like this. Now if you are processing this thing, you see that everything is occupied, you cannot do anything. So what do you do? You pick the one with the lowest ending time, because that is the one which will get free first. So this is the one which will get free first. Okay. This will be free first. So you occupied that one only, which will get freed first. So it's very simple. What you do now? You add the whole duration to this. So this is the duration of 5. Okay, and this is ending at like just before 5. So you just do 5 plus 5, 10. So it will be nothing but 5 plus 5, 10. You add the duration. You are storing the ending times, right? So you just add the duration, and you see now 2 meetings are held in the last one. The 2 meetings are held in the last one, and you see again that this 6,8 means that you need to wait again for one meeting to get over. Now these 2 meetings will get over simultaneously at time t. Out of the one, this is the one with the lowest room number. Okay. So since this will get over first, will have something like, we will add this duration 2. So now we will get something like 20, 12, 10, and we will have the final count result as this. So this is the status, this is the count. One meeting is held at room 1. Okay, one meeting is held at room 1. 2 meetings are held at room 2. 2 meetings are held at room 3. So you need to return the maximum room number, or maximum in the room number in which the maximum meetings are held. So there are 2 such rooms, right? So if there is a tie, you return the room with the minimum. This is the room number 0, this is room number 1, this is the room number 2. Since 1 and 2 gets tied, you return the room number 1, because that is having the maximum count of meetings, and also with the minimum room number. Okay, so you return this as your answer. I hope you understood how to perform the simulation. Okay, this is a simple brute force method. This is completely brute force. Okay. So if you try to see what is the time complexity of this, so first of all, you are sorting it. You are sorting the whole array. So let's say this has meetings have a length of m. So m log m will be the time complexity, and you are also, for every, you see that you are going through all the meetings. Okay, you are going through all the meetings, and every time you are checking the status from the beginning. You checking from the beginning I, you are checking the status. So this has a length of n. N is nothing but 100, right? So every time you are going through this array m for all the elements in m, so you have something like n into m also. So you see O of n into m, these all of these things will pass. Actually, the whole thing will pass. So what can you do now? You can try to just simulate it. As I had told you, you just simply try to simulate it. That will be all. Okay. So let's see how to simulate the thing. Let's see quickly. Okay. Let's just see quickly. Uh, what are the things which we need to do? We need to have a count array and a status array. Let's keep size of the meetings in capital N value. Okay. So this is nothing but meetings dot size, and you have two vectors which is given by count and also the status, right? Okay. Now you definitely must see that the status shows the ending time, right? Now ending time is getting added again and again. This ending time is getting added again and again. So let's see, you have you earlier has 0 here, then you have 10, then you have 12. So it is getting added again and again. So you see the each of the length is nothing but 1e5. Meetings dot length is 1e5, and the values in the meeting, you see the values in the meeting are 5e5. Okay, so it can get exceeded. So I will try to use a long here. I will try to use a long here. So there are the things that you need to take care of. I hope that does not come under the logic. So whatever be the case, I have just told you, and we'll see. We will maintain this whole thing. We will initialize to 0. So it has already will initialize to 0, and we will now simply sort this meeting. Okay, meetings dot begin, meetings dot end. Okay, because we need uh, earlier start time first. Okay, now I will iterate through all the meetings. It's become very simple now. We'll just iterate through all the meetings. What I will do initially I will check if there is any free room available. Okay, if there is actually any free room available. So what will I do? Can you tell me what will I do? If I get something like this, I'll just go through my entire status array, and I will just check whether any room is free or not. So for first thing, I just write the starting meetings of I0. It means that starting time. This is the ending time. Let's make it long. Let's make it long. This is the ending time. Meetings of I, and let's have a duration also, right? Let's have a duration which is nothing but ending time minus starting time. So I just had it, starting time, ending time, and the duration. Now I will go through all the elements in status. Okay, so I just go through all the elements in the status array, and I will check that if first thing is that if the status of I is less than or equal to my starting time, then what do I need to do? I need to see that I have got something. I have got some. So let's see. This is both I am doing I, which is not visible. So let's make it J. Okay. So you see count of J. This J room. We are iterating through all the rooms, right? See status of all rooms. So status of all rooms, it means that go through all the rooms and check which is empty. So room J is empty because it has already ended. You see the status J is less than or equal to. You find that the status J is nothing but the ending time. Ending time is less than or equals to the current starting time. So you have this room as empty. So you just iterate. You just will occupy this room, right? So you will be holding a meeting right now here. So you have this, and you will do what? You will again occupy this status with the ending time. Okay, you just occupy the status with the ending time. Now you might ask that what if no rooms are empty? So what did I do here? If you remember, what did I do if no rooms were empty? I picked a room with the smallest one. Okay, with the smallest status, with the smallest ending time, because that is going to be free first. Okay, that is going to be free first. So uh, I pick the room which is going to be free first. So what will I do is that I will have a minimum array, minimum element. Okay. So what will I do is this is that I will also have a minimum index. Okay. And I will track which is the minimum, which is going to be free first. Okay. track which element. So whenever you find a room, you can just break out from the loop also. You can just break out from the loop. Track which element, which room will free first. Room will free first. That is lowest starting time, minimum starting time. Okay, minimum uh, ending time. Ending time. So ending time is the status. So you just do minimum. So if minimum, you do something like if status of j is less than this minimum, what you do is that you just store this minimum array uh, about this status j, and you also have this minimum index which you can easily do j. Okay, you have the minimum index. So what you see here, you see that if no room, if actually all the rooms are occupied, so how will I check whether a free room is found or not? Okay, so let's keep another variable found. Okay, which is 0. And if room is found, I will do just found equals to 1. Okay, hope you get it. And when it will go out from the loop, if you did not find any room which is empty, if you did not find any room which is empty, pick the room with the smallest ending time. Okay, we pick the room with the smallest ending time, which is nothing given by nothing but the minimum index. So pick the room with the smallest ending time. So I will do count of this minimum index plus plus. It means that I am now going to take place, a meeting is going to take place in this room with the minimum index. And it will, what time will the meeting go on? That's the question. Till the time where plus equals to previous value plus the duration. Okay, previous value plus the duration. Duration, I just get added up. I just get it added up. So I hope you understood this easily, right? This is a very simple method. So if you just find it, just do it. And what do you need to do apart from all these? What do you need to do? You just pick up the element with the maximum value. Okay, so maximum index, you just pick up the count with the maximum value. And if there, in case of ties, you also need to ensure that you pick up the first index. Okay, so what you will do is very simple. You go through all the counts. You go through all the counts. You try to track the maximum value. So if it's like maximum is less than count of I, then you do nothing but maximum equals to count of I, and you also have a maximum index. You just make it I. Okay, and this, when it is strictly less, then only do it. It means that for equal values, it will just take the first, it will just take the first occurrence. Okay, and just return this minimum index. That's what you need to return. Let's try to run and check if we have done everything correct, or there is some error in our code. uh, Return maximum index. I'm returning minimum index. So this is the maximum index which I need to return, the one with the highest value of the count. So you see, we have an accepted case. Let's try to submit it and check if it works. Let's try to submit it and check if it works for all the cases. So you see, it does work for all the cases, but we have a 50% bits. Can we make it better? Can we make it better? So you see, in order to see the status of the room, what was the time complexity? If you try to see, time complexity was n into m. Why this n into m is coming? Because in order to see the status of the room, for every meeting I, you are going through all the rooms, which is n. Okay, so instead of having all the rooms, okay, instead of having all the rooms, can you, instead of going through all the rooms, can you do something which will automatically give you the room with the minimum ending index? Okay, so you need the room with the minimum ending time, right? So what type of data structure come to your mind which will automatically give you the minimum one? It gives the data structure which comes to your mind is minimum heap, right? Minimum heap. So the method which I am going to show now, it is very difficult if you have not solved this problem, similar problems earlier, but you try to just know it. Just try to know this method. So I already told you, instead of iterating through the array again and again to see the status, you try to check you try to check that which rooms are already occupied, and among the occupied rooms, which are the ones which will give me the minimum ending time. Okay, so a heap or priority queue, is the data structure, and since you want the minimum ending time and also you want the minimum room numbers, okay, so what do you do? Since you want the minimum ending time and as well as the minimum room numbers, you maintain a minimum heap. Okay, minimum heap. Oh, and if you don't know how to initialize a minimum heap, you just search in the GFG how to just you just search in Google. You will get in GFG how to initialize a minimum heap. Okay, min heap. It is also known as a min heap. That is done using priority queue. So I will write the syntax directly here. Okay. I hope you will search it and understand it if you don't already know it. So we will maintain two priority queue. We will maintain two heap. One will be a free rooms, okay, which will tell you that which rooms are free now, okay, so that you can select the one which the lowest room number which is free, the lowest room number which is free. You just pick it up, right? You can just pick it up from the top of the priority queue. And which are the rooms which are occupied? Among the occupied rooms, which are the ones with the lowest minimum time, which is the one with the lowest ending time? You can just pick that up. Okay. So this free room will contain nothing but the room number. Okay. And occupied, why I am doing occupied? Because in case of no room is free, you need to start with the lowest ending time, right? So it will have a pair. This minimum heap will have a pair which is ending time, comma room number. Okay, which is ending time comma room number, and ending time, it is long. So this will be a pair of type long comma int. Take Make sure to take care of that. So what you do, you first of all initialize a minimum heap. So I am initializing a minimum heap. So it's given by int vector of int and pair of creator of int. Okay. Also, if you don't know the syntax, just quickly go and check. And initially, all the rooms are free. So you go through all the rooms and make it free. Okay, free dot push I. So you do go through all the rooms and just push it. Okay, and you also initialize something occupied. Okay, priority queue of occupied. I am initializing a minimum heap, uh, and instead of integer only, you have a pair, right? Instead of this whole integer, you have a pair. So what do you do is very simple. Pair of long comma integer. Okay, so what you do is very simple and very interesting here. Instead of this integer, you have a pair long comma integer. Okay. So what do? You just do pair long comma integer. Okay. So I hope you easily understood what I did just now. And this is nothing but occupied rooms, right? These are the rooms which are occupied right now. Okay. And now what I will do, I will just, you see these things will be the same, right? If I am maintaining the count array, and these things will be the same. So this is the way of iterating. Just I told you that instead of iterating every time through all the status, I will just maintain a priority queues which will give me the top elements, right? So I hope you understood what I am doing. Okay, so I will go through all the meetings and I will do the same thing. I will do something like the start time, which is nothing but meetings of I0, the end time, which is nothing but meetings of I1, and the duration, which is nothing but end time minus start time. Okay, end time minus start time. Okay, now you see, at first you need to check that, let's say you are going to put in any of the free rooms. Okay, but some rooms are already occupied, right? But what if by the time you are going to occupy some free rooms, some rooms which are already been occupied, that are also becoming available, that may also become available, right? So some rooms are occupied, some rooms are free. So if you cannot just blindly go to the free room and push, you can just blindly go to the free room and occupy. By the time you are occupying, some occupied room may also get freed. This thing you understand, right? Some occupied room may also get freed. So you check which occupied rooms are getting freed. So how can you do that while this occupy priority queue is not empty, and this occupy dot top dot first. I hope you understand, right? This first element, you pick the first top element. That is giving you the ending time, right? That should be less than or equal to my current starting time. While that is current starting time, so I am checking that by the time my meeting is starting, by the time my current meeting is starting, how many rooms are getting freed? How many rooms are getting freed? How will you free a room? You pop it from the occupied. It is no more occupied. You add it to the free rooms. So free dot push will be something like occupy dot top dot second, right? Second is the room number. I am iterating in the room number. So that's what. I hope you easily understood this. What I did. I just took the top room. I just took the top room number. That is with the room number with the minimum ending time, and check that if those times are less than or equal to starting, that is becoming free. That room has become free. You just push it in the free room. Okay, you just push it in the free rooms, and you just pop the occupied. Okay. Now you check if any room is free or not. So if free dot size is greater than 0, you check that if any current room is free, then what will you do? You will blindly do something like, what will you do? You will occupy that room, right? You will free the room which is free will no longer become free. So you do free dot pop and you occupy that room also. So how do you occupy exactly? You start, you have the ending time, you give the ending time to that, and you say what is the room number which you are occupying. It is nothing but free dot top. This is the room number which you are occupying. Okay. I hope you understood this, right? I hope you easily understood this. If free dot size, if you have something free, then you push it in the occupied array. You push it in the occupied array of the ending time and free, and you just do free dot pop, right? You just do free dot pop, and you can continue with this. You can continue with the next iteration. No need to see what's going on next. If the room is not free, now if the room is not free, what can you do? What can you do? So if the room is not free, this free dot size will be 0. And now you need to do the thing which is select the room number with the minimum starting, minimum ending time, right? Okay, now you select the room, select the occupied room with minimum ending time. It is nothing but the top of the priority queue. You top of priority queues, from the top of the priority queue, you will get it. So what do you do now? You go to the top of the priority queue and just check. Okay. So you see, you are selecting the occupied room. So you will have something like end time of from that occupied room, occupied dot top dot first, and you will also have a room number. Okay, I guess you will also have a room number from this occupied dot top and dot second, and you will have occupied dot pop, right? Because you are freeing that room, you are waiting till the time the room becomes free. Okay. And what do you do now? You need to occupy that room again, right? You have freed it and you just now need to occupy that room again. So what do you need to do is again very simple, is that you just do occupied dot push end time plus the duration, because this is the time which by which you are occupying. Okay, this is the time which you are occupying, and this num is nothing but this index. Okay. I hope you understand this. I hope you understand this easily. And I might be missing out some things, right? Can you tell me if I'm missing a if free dot size is? Let's see. Let's run the code and check if I am actually missing out something. And let's check if I have done everything correctly. So you see, I have not incremented the count. So if room is free, you also need to increment the count, right? So you go to this room number and increment the count, because that is going to a meeting is going to held in that room. And for this also you just need to increment the count in this room number. A meeting is going to held. So you just increment the count here also. So two places you just incremented the count, and if you just try to run this code and check if it works, or it has some error, then we will try to debug it. You see, we are getting a wrong answer for a very large test case. Otherwise, for some cases, we are getting correct. So if you try to sum it and check how many cases are exactly passing, you see 80 out of 81 cases are passing. So one case, only the one edge case is missing out. Okay. So you get a hint of what we need to do here. What we need to do here. So you see this ending time, let's make it LL. Will that work? Is that going to work? Because this ending time was in our thing, right? Uh, let's see if it works. So you see, that was all the error, right? You cannot store it in an integer. This ending time, you cannot store it in an integer because, I mean, that is a long which you are storing, right? In the first pair, first element of the pair is a long. So you see the accepted case, it is not showing much greater, but it is actually very optimal. It is instead of that m into n term, you are doing nothing but log m. So you see, I run again and it is giving 94% bit. So I hope you understand that this is actually much optimal than the previous solution. So yeah, that's all. That's all for this video. This was a hard problem to come up with if you have not already done this similar problems of this priority queue thing. Okay, using two priority queues to solve these kind of problems. Uh, anyways, I hope you learned something new from this video definitely, and I hope your day is going to be really easy. Thank you so much.